Alright, so today we are talking about the square root parent function. His name is Squidward. And so we introduced this at the very beginning of the year. Here is the equation, f of x equals square root of x. And so if I were to plug in these x values over here, square root of 0 would give me 0, square root of 1 would give me 1, square root of 4 is 2, square root of 9 is 3. And so when I plot these points, I have the point 0, 0, 1, 1, 4, 2, and 9, 3. And so he looks like this. Now, it's important to note that you cannot take a square root of a negative number. And so if I were to type in square root of -9 into the calculator, it would give me error. Okay, you can't take square root of a negative number because there's nothing real that if you square it will give you a negative number. Okay, and so for the square root parent function, you can't put anything negative into the radical. You can't get anything negative out of the radical. And so that's why we have this blunt starting point. And that's not a mathematical term, it's more of just a characteristic of the graph. We call it a starting point because it's just a blunt end. We don't have an asymptote, it doesn't taper off and get closer and closer and closer to that point. It just stops. We can't have negative x values and we can't have negative y values. And so we want to keep track of that starting point because it helps us keep track of transformations. And so the starting point for the parent function is always going to be the origin 0, 0. And when we do our transformations, we're going to keep track of where that moves left, right, up, and down. Okay, and so this parent function, Squidward, his direction, we want to keep track of the fact that he's going to the right. That's going to help us with domain. And he's also going up. That's going to help us with the range. So Squidward here is going up and to the right. And so the x-intercept for the parent function is 0, 0. Right there where he crosses the x-axis. And so obviously that's also our y-intercept, because that is also where he crosses the y-intercept, the y-axis. Now this is the very first function we've seen that does not have any type of symmetry. When we were dealing with cubic, cube root, quadratic, or absolute value, they either had an axis of symmetry, meaning we could flip it and it would look the same, or they had rotational symmetry, meaning we could rotate the graph and it looked the same. Because we have this blunt starting point, there is absolutely no symmetry for the square root function. He's the only function we have like that. Okay, and so the domain, because he starts at x equals 0 and is going to the right, we are going from 0 to infinity. And this time we have a bracket rather than a parenthesis because he does actually equal that point 0. And then same thing for the range. He starts at 0 and he's going up, and so bracket 0 to infinity. Remember, your infinities will never ever ever have a bracket. Always use parentheses for infinities. Now for the max and min, we have what is called a global min here. This starting point is a global min. So no matter which interval we start looking at, which we'll do on the back, we need to keep track of where that starting point is, because if it's on the interval, it's automatically going to be one of your extrema values, either your max or your min. So in this case, our parent function does not have a max on his domain because he's going up forever, but he does have a minimum at 0. And so this point, the starting point, the y value is his minimum. So remember, max and min always refer to a y value. It is a value, not a point. I mean, not a number. Gosh, not an ordered pair. Okay, and so now that we know the parent function, we're going to recap all of our transformation rules. And so we know that plus 5 outside the parentheses moves up 5. We know minus 5 outside the parentheses moves down 5. And so that was true for our absolute value function. That was true for our quadratic function. That was true for our cubic parent function. And it is also going to be true for our square root function. But this time, inside and outside the parentheses corresponds to inside and outside the radical. And so you have to be very neat about where your radical ends. And so we have to make sure this plus 5 does not end up under this radical. Same with the minus 5. Now if we do want it in parentheses, we know that plus 5 moves left 5 inside, and we know that minus 5 actually moves right 5. Everything inside the function is backwards and crazy. And so this time, make sure it's very clear that your plus 5 is inside the radical, and the minus 5 inside the radical. And so on Canvas, if you were to type in these answers, we don't have a way to type in the square root. And so you will be using the notation SQRT parenthesis x minus 5 close parenthesis. And then for this case, you would have SQRT just x in the parentheses, and then your minus 5 outside. And so that's how you'll be typing in your answers. Your radical will be replaced with SQRT and parentheses. Okay, and then for the negative outside, we know that's our x. For the negative inside, we know that's our y. And so here we would have negative square root x. Here we would have negative x on the inside. Now remember, we can't take square root of negative numbers, and so having this negative here isn't a problem. It just changes what we're going to be allowed to have in our domain. Okay, we know 5 outside is our vertical stretch by 5. We know a 1/5 would be called a compression, but it's still vertical. If you put that 5 inside, that's your horizontal compression, because everything's backwards and crazy. And then a 1/5 inside would be your horizontal stretch by 5. Inside the crazy house, flip it. Okay, and so for a radical, it's outside the square root versus inside the square root. Pretty easy. Make sure your radical's nice and tall if you have that fraction. Okay, and so the same rule about good form always applies. If you have a coefficient on the x, you need to factor it out and have an extra set of parentheses so that you can keep track of right and left, up and down. And so if you have good form, this number right here after a minus sign is going to be the x value of the starting point, and this is going to be the y value. So HK will be your starting point. Remember, if that's a plus sign, that means your x value was negative because it moved left. This is going to help you with your domain and range, whereas the A and B value, that's just your stretch, compressions, and reflections. And so